dynamics across continental Asia are still unknown. In this frame, the evolutionary history of Asian Homo erectus remains obscure. Over 250 hominid dental elements currently represent the Asian Homo erectus record. Most of this material consists of permanent teeth and jaw fragments. However, even if quantitatively rich, this assemblage is historically concerned by a number of problems and limiting factors, and this is partly due to the intrinsic heterogeneous nature of the fossil record, of course. But in addition, the sea level aesthetic fluctuations that cyclically affected the Sunda region during the Quaternary were responsible for the formation of temporary land bridges and the possibility for intermittent faunal exchanges between the mainland and insular Southeast Asia. So in this dynamic scenario, isolation phases have periodically shaped biodiversity at regional scale. And all of these issues have recurrently affected the reconstruction of the local evolutionary trends. So for all of these reasons, the taxonomic attribution on some of the Indonesian specimens, such as the trinil molar that you can see here at the bottom, has been continuously debated since over a century. Tooth remains usually represent the most common evidence testifying to the life of extinct taxa. A significant amount of valuable biocultural information is preserved within tooth crown and roots, and this allows the assessment of critical aspects concerning the taxonomy, evolutionary pathways and phylogenetic relationship, sex and age-related models of developmental timing and patterning, life history traits, the diet and ecological strategies, paramasticatory behaviors, health, seasonally related fluctuations, and so on. Thus, tooth structural morphology plays a critical role in hominid systematics. Studies of the external crown morphology already highlighted some trends occurring at continental scale, notably between Africa and Eurasia during the early and middle Pleistocene. But these studies are limited by some factors inherent to the preservation of the external tooth morphology, such as occlusal wear, degree, and taphonomic processes. Recent developments in virtual paleoanthropology now enable extracting the internal structure of tooth tissues, and studies suggest that the external morphology of the enamel tend to reflect microevolutionary processes. It is also generally more affected by occlusal wear. On the contrary, the underlying dentin is more conservative and generally less affected by occlusal wear. In fact, the enamel-dentin junction, which correspond to the interface of dentin below the enamel cap, is a very accurate taxonomic marker, allowing to discriminate up to the subspecific level in hominid taxa. In this study, we used advanced methods of virtual imaging in order to characterize the subtle inner structural morphology of dentognathic remains from the Middle Pleistocene site of Shukutian in China and from the early Middle Pleistocene deposits of the Sangiran Dome in Indonesia. For comparative purposes, we also considered dental material representing South African early Homo, North African Homo erectus, Neanderthals, and extant humans. The analysis of the enamel-dentin junction shape globally shows that Asian Homo erectus specimens have an intermediate morphology between Neanderthals and modern human. More precisely, for the lower premolars here at the bottom, the Chinese teeth from Shukutian, shown by a star, exhibit a similar shape than African early Homo specimens, which are grouped here as a triangle and a cross. And they all fall apart from the late Pleistocene and Holocene variability. However, when considering the upper canine and the upper front molar shape, the Indonesian and Chinese specimens are still intermediate, but exhibit some degree of variability. So For example, you can see here are the Indonesian specimens, and here is the Chinese one. But this degree of variability does not exceed the one of the Neanderthals. So, of course, this analytical sample is still too limited to be conclusive on any of these aspects. But when looking at the subtle occlusal morphological details of the enamel-dentin junction, it is evident that two groups can be recognized. During the early Pleistocene in Indonesia, the crown displays a complex occlusal pattern, as illustrated here by the specimen Sangyan 4. And even if the early Pleistocene Chinese condition is still unknown, the presence of a similar but even more complex pattern later during the Middle Pleistocene suggests a common source population. However, during the Middle Pleistocene, we also note a distinct morphology in Indonesia. These teeth show simplified crown and are more similar to modern human. So, to sum up, the archaic morphology is a low crown with a complex occlusal morphology that is then found also until the Middle Pleistocene in China, while in Indonesia you have taller crowns with different cuspal position that is more similar to modern humans. So more evidence is needed to understand if such differences between continental and insular Asian groups around the early Middle Pleistocene boundary reflect separate evolutionary trajectories, admixture with other populations, or simply a biased sampling of the Asian Homo erectus variability. Nonetheless, it is noteworthy that the current evidence based on dental structural morphology does not seem to reflect the studies based on cranial morphology, and these latter suggest a virtual evolutionary continuum from the early to middle Pleistocene in all Asia. But in addition, the Asian dental record attributed to Homo erectus exhibits an extraordinary degree of morphological and dimensional variability. Historical debates on this issue mostly centered on whether the Javanese robust specimens belong to only one species, Homo erectus, or if multiple hominid taxa were rather represented in the Indonesian record, such as Meganthropus paleojavanicus, Pithecanthropus dubius, or Pongo brevirostris. While the question is still controversial, based on a number of scattered evidence from China, Vietnam, and Indonesia, the debate on a still unrecognized fossil pongine taxon, which is called now the mystery ape, has been recently relaunched. This taxonomic uncertainty is also due to the convergence in crown size and morphology between Pongo and Homo. Indeed, both taxa exhibit similar time-related evolutionary trends for dental structural reduction throughout the Pleistocene. In addition, occlusal wear acts as an additional confusing factor by removing the fine structural details of the external morphology, and all of this seriously limit any reliable taxonomic identification. Among the most debated specimens are the two emblematic trinil molars that were recovered by Dubois in the early 1890s. In 2009, following the investigation of their bidimensional inner morphology based on a synchrotron radiation microtomographic record, they were reallocated to Homo erectus. But we analyze here for the first time their 3D internal structure. We also analyze the molars of the robust mandibular specimens like Sangyan 5 and Sangyan 6A that were previously attributed to different taxa, naming Pithecanthropus dubius and Meganthropus paleojavanicus. The specimen Arjuna 9 was found in stratigraphic context in the early Pleistocene grassbank zone of the Sangyan Dome. Because of its large dimensions and primitive morphology, it was first compared to Meganthropus, but it was later reallocated to Homo erectus. It is noteworthy also that the second molar of Arjuna 9 very closely fits that of Sangyan 5. And finally, the isolated molar FS77 was recognized by von Königswald as a Meganthropus specimen and will be included also in the analysis. We compared these robust specimens to a sample of 15 unambiguous Homo-Erectus from Indonesia and China. Most of the Indonesian teeth come from a controlled stratigraphic context, from the early Pleistocene Punchangan Formation and from the late early to middle Pleistocene Kabu Formation. A first line of evidence comes from the topographic distribution of enamel thickness. Fossil and extant human molars are characterized by having their thickest enamel located on the lateral aspect of the functional cusp. So in the upper molar, the thickest enamel is found on the lingual cusp, while on the lower molar, it's the contrary, they are found on the lateral aspect of the buccal cusp. And here you have modern humans, Homo erectus from Indonesia, North African Homo erectus. In fossil and extant pongo, the thickest enamel is found all around the marginal ridges at the periphery of the occlusal basin. In this context, the upper molar from Trinil, here, and all the robust specimens from Sangiran all show peripheral pattern of thicker enamel close to the pongo-like condition. When looking at the enamel-dentin junction shape, fossil and extant human comparative sample that include Neanderthals in red, modern humans in gray, and the unambiguous Homo erectus teeth in green here, all show a similar general pattern. And the human specimens are clearly separated from the fossil and extant pongo groups. And then again, both trinil molars, they fall close to the variability of pongo and are characterized by a pongo-like enamel-dentin junction topography that significantly differs from the human condition. Then a similar analysis was conducted on the lower molars. And again, while all the more gracile Homo erectus specimens fall within the variability of extant and fossil humans, and you have here again the modern humans, Homo erectus in green, Neanderthals in red, and the 2 points here are North African Homo erectus. The robust specimens, on the other hand, are separated from the human group and are discriminated among the Pongini. So Arjuna 9, Sangiran 5, and Sangiran 6a all show a low enamel-dentin junction and the typical pongo-like organization. However, it has to be noted that these robust Indonesian specimens also all exhibit a very developed protostelid expression along the buccal aspect. And this protostelid that forms like a buccal cingulid is never seen in any of the fossil or extant pongo molar investigated so far. And as you can see, it is neither present also in the Homo erectus specimens. So as a whole, these results point to a likely more complex Indonesian early Middle Pleistocene hominid paleobiodiversity than usually recognized. And we can assume that there is something that I will call the mystery ape, represented by the robust specimen from Indonesia. There is safely Homo erectus, and there is also pongo. We also recorded some subtle inner structural differences between Indonesian and Chinese Homo erectus representatives. But the possible meaning of these differences remain to be assessed on larger samples and at larger scale in order to better appreciate the complex nature of the intermittent exchanges that occurred between continental and insular Southeast Asia. And in conclusion, I would like to point out that even if finding more new fossil material is absolutely essential to better grasp details of the early Homo evolutionary biohistory, it is nonetheless also necessary to reassess the already available specimens in the light of new investigative approaches. Thank you for your attention.
Thank you, Clément. You have kept the time very well. You have some very interesting results. Questions, please, for Clément.
Yes?
Yes, Rick.
I know the kind of analysis you're doing can be done on isolated teeth, but on the basis of your findings, do you have an opinion about
Well, these specimens, the Sengeren 6A,
Wasn't there a jaw fragment as well?
it's jaw fragment, and I extracted the first molar, this one, to do the analysis. But this is the Meganthropus, the holotype of Meganthropus palaeogermanicus.
All right. More questions for Clement? We have 7 minutes for questions. Anyway. 7. You've given everybody 7 minutes for questions, now they don't want to ask. So.
Okay.
Anyway. One more question. Good. Then everything was perfect, nobody wants to know anything. Good, thank you. All right, and now, it's actually interesting. We have one colleague here who managed to give 2 talks. Jeff Schwartz, I don't know how that happened, Jeff. Anyway, so we're happy you are back again. Anyway, now Jeff Schwartz and Ian Tattersall. So Jeff is giving the talk. You need one? You taking his minutes? Yeah. No, Jeff. Anyway, that's okay. All right, so Jeff Schwartz and Ian Tattersall now on diversity versus variability in human evolution, the case of Homo erectus.
Thank you all again. And again, thanks to the organizing committee for making this possible for us to be here. And also I want to thank David and everybody in the Dmanisi crew for providing not only the fossils, but also an environment where we can agree to disagree. So in terms of summarizing what's been talked about earlier today, variation is the preferred explanation of morphological difference. So we can ask the question, how does and can one a priori identify variation? In other words, when does intraspecific demic variation end and taxic identity begin? From a systematic point of view, the question is, can one delineate at least one derived feature that warrants referring specimens to one group or another, whether you refer to them as morphs, species, or whatever? For only after allocating specimens to groups can you describe individual within group variation. To rephrase then, how can one identify variation between individuals within a group, whatever you want to call that, without first using some criteria or criteria to establish the boundaries of that group? Another thing is that one taxon's expression of variation, whether it's hard or soft tissue, doesn't reflect nor should it serve as the standard for identifying variation in another taxon, nor is the evidence for recognizing taxa the same for all taxa. So I'm going to give 2 examples before I get to the fossils. One is variation within the given species Hylobates, LAR, and essentially there's nothing. You can put a zillion of these skulls and mandibles on a table, and they look the same. The only way you can discriminate between these is sexual dimorphism, but on primary sexual characteristics, which of course are not preserved. Now another thing is that such animals as sheep and goat are referred to separate genera, and there are various species that are allocated to these genera, but there's very little that actually distinguishes them, except for coat, ears. The horn cores are very different. They're flattened in Capra, and they're more trapezoidal or subtriangular in Ovis. Whereas in some cases, mandibles and teeth are good distinguishers between different morphs or species. It's impossible to do this with sheep and goat with accuracy. Perhaps in terms of the condyle, there are differences. And if we look at postcrania, the differences are also very minute. And most of the skeleton cannot be distinguished one taxon or the other. So let's turn to the morphological differences amongst the Dmanisi hominids. And the question, do they represent variation, or are they systematically and taxically relevant? So in putting this together, as Christoph reiterated earlier today, I want to think about the questions they raised, about the specimens with cranial shape within the early Homo paleodemus being similar in mode and range, as seen also in Pan. And also, as Christoph summarized, that the pattern and ranges of variation in the hominids match those or are represented by those in chimps and a global sample of Homo sapiens. So in this talk, I will actually talk about morphology and see what the bones tell us. So I'm going to use the same illustrations. And the thing is that Christoph is right. There are differences from one chimp to another, which are basically sexually dimorphic, such as size or the development of sagittal crests. Some have more robust or thickened brows, and some have longer faces, and so on. But in reality, amongst hominoids, there aren't that many that develop a post-tural sulcus, as indicated by the arrow here. So every one of these specimens actually has a post-tural sulcus. The only extant hominoids with them are chimps and gorillas, and their individual detailed morphology is very different. They're straight across in gorillas, they develop that way, and they are more undulating in chimpanzees. Another thing is that you can always identify chimps by their teeth, and they have particular patterns of crenulation as well as cusp configurations. So going back then to the comparison between the Dmanisi specimens and Pan, what I would ask is, can you actually equate the two in terms of the differences? In other words, if you had a chimp skull, would you predict that another skull would look like that if it belonged to the same species? And indeed, as Christoph also pointed out, there are differences amongst the Dmanisi specimens in terms of cranial shape and other sorts of features in terms of the brow. So if I ask the question, would you be able to predict from one skull of a chimp or Homo sapiens that the next specimen that would belong to that species would look similar to it? The answer would be not if you had skull 5. You would not be able to predict that, in fact, 2880 would be the morphology that you would expect. And indeed, the differences in terms of the configuration of the brow, the development of the post-tural sulcus, and so on, exceed at least the degrees of variation as seen in these chimps. So let's look at a different approach and compare Pan with Homo sapiens. And some years ago, I did a detailed study of over about 500 humans, extant humans, from known localities prior to colonization and so on. And this is just the representative of the range of variation which we see in Homo sapiens. And there's some things that I've discussed elsewhere in terms of the development of the brow. More specifically to Homo sapiens is the development of the so-called chin, which I've identified as an inverted T-shaped structure. And we can see that there are differences in terms of length of the face and breadth of the face and the robusticity of the mandible, but they are still Homo sapiens. And I put in these Australian Aborigines because they indeed do have the most robust features, as people know. But the other characteristics of the skull, as well as the basic cranium, which we've outlined in our fossil record, features that are specific to Homo sapiens, as well as dental morphology, unites them all as Homo sapiens. And indeed, I think this is mirroring what we see in chimps. And comparing this then with the Dmanisi specimens, I would again suggest that the differences amongst the Dmanisi specimens exceed the differences that we see in this global representation of Homo sapiens. So that's exactly what I said. I think the morphological differences of individuals with Pan and Homo sapiens do reflect morphological variation, and the differences amongst the Dmanisi specimens something else. So let's try a different approach. And everybody's been talking about Homo erectus from Africa, but we have to remember that the type specimen of Homo erectus is Trinil 2 from Java. So let's look at some of these specimens. First of all, there are very distinctive features of the type specimen, which I've discussed elsewhere. You can look at the arrows. Yesterday I talked about this very odd configuration that we see in Trinal 2, where the cranium is wider from side to side than it is tall. And that's very unique amongst hominoids or catarrhine primates in general. And there's also the long slope going from the supraorbital region up into this long sloping frontal, and of course the well-known V-shaped occipital. So we can go from the Trinal 2 specimen easily to Sangaron 2 in terms of features of the cranium, in terms of the depression in the brow, which is unique to these two specimens, and also we can then refer to other specimens from Sangaron that I think share the same unique features of the type specimen, but in this sample represent individual variation from something that's very gracile to something that's very robust, as in this Sangaron 4 specimen. That, I think, is variation. And if we look at them from the rear, as I showed you yesterday, they all have this wider than tall configuration, but they differ in terms of robusticity, in terms of this sagittal bulge. Sangaron 17 is the outlier. People don't know necessarily that this is more than twice the size of the cranium of Sangaron 2 and Trinal. And then we can look at some other Asian specimens, such as from Nangdong. And they're pretty much uniform in their morphology, differing in whether they're a little more robust or thicker and so on. And here I just want to emphasize that, for instance, they have this very unique configuration of the brow where it's straight across from side to side, and then it thickens laterally. So we can go through all of these specimens, and they show this as well as other features of that group, in which I would also include Ngawi 1, Samuchon 3. And clearly, this bunch looks like one another. In other words, if I had this, I would predict that I would find another one that looked like that if I thought it was, this was a separate morph or whatever. And they differ distinctively from Trinal 2. The same thing when we look at them from the side. Indeed, there is a continuum from the supraorbital region to the frontal, but the plane is different. The angulation at the back of the skull is different, and in fact, we also have this laterally thickened brow. And from the rear, they also differ significantly from the type specimen of Homo erectus in terms of this more rounded, semi-vaulted shape. Now, going to the Zugudien specimens, they also seem to be uniform within themselves, but differ in terms of robusticity or degree of expression. And one thing that I'll just point out is that there's this undulating, sort of uniformly thick supraorbital extension that is in fact depressed in the midline. And if we go through all of the specimens, they do demonstrate that, including the subadult from Zugudien 109. And in these features, they differ significantly from the type specimen. If we look at them from the side, they're one of the few hominids that has anything that I would consider to be a post-toral sulcus. And you can see that it's delineating this three-dimensional brow that has some sort of superior element to it, which is not reflected in the type specimen whatsoever. And in terms of the posterior profile, you can see that the rear of the skull and the whole contour of the profile is different in the Zugudien specimens compared to Trinal 2. So I would consider this also to be variation within that assemblage of specimens. Then if we now go to the East African specimens, none of them shares any of the features that would distinguish Trinal 2. And indeed, each of them presents a different morphology. 15,000 as a subadult would never develop into looking like one of these. It already has an elongate, narrow face, a tall, semi-narrow nasal aperture, and mounded brows and a rounded skull. 3733 has a sulcus, which is defined by this very thin, superiorly projecting brow with the peak, which is anterior on the skull, whereas in 3883, the peak is posterior on the skull, and the brow is a totally different configuration from the three of them. So what I'm suggesting is that morphological uniformity amongst the specimens from these different locales, Trinal Sangaran, which I would put together from Nangdong, and I would include now Ngali and at least some of the Samumachan specimens, and also from Zugurian, suggests to me at least that each group represents a distinct morph. And because these are separated in some cases, like with Zugurian, geographically, and also these sites are separated chronologically, I think that this might be reasonable to suggest that these morphs are taxonomically distinct entities. In light of those comparisons, then the Turkana specimens themselves do not constitute a group. They don't show that variation within uniformity, and that this is, calls for their taxonomic reevaluation. But if we want to consider these morphs as demes, the question then is, do the Dmanisi specimens present a similar morphological uniformity within them? And I think, as I've tried to suggest, that my morphological answer would be no. The other thing is that what struck me listening to the talks on the fauna is that, especially the one just this afternoon, is that if the differences between the Dmanisi hominids represent intraspecies variation, or indeed these specimens constitute a paleodeme, why isn't this the case also for the felids, the mustelids, and the cervids, which are identified as different species, if not also different genera? So I've seen all the specimens. I've so far been able to describe and photograph these three, so I'll just refer to these and suggest that these do not themselves present the kind of variation within uniformity that we saw in the Zugurian specimens, for instance. And that if we had 8.0, we would not predict that we would find 2700. And again, looking at the profiles, they are indeed different, as we've seen before, and also the rear profile, the configuration of the occipital and the lambdoid suture, the place on the skull, which is widest, is in different areas, and so on. So as I've been emphasizing, I think the point is not only predictability, that if you had a specimen and you thought you would find more of that species, that specimen would predict what that would look like, is that the uniformity between them. And in this perspective, then, the differences between the Dmanisi specimens and Turkana specimens is that they're just different. So to conclude, since the morphological difference reflected in this sample exceeds the range of morphological difference between individuals of Pan and Homo, I cannot at least easily equate the differences amongst the Dmanisi specimens with variation. And indeed, since no specimen from Dmanisi presents any of the derived morphologies distinctive of the holotype of Homo erectus, Trinal 2, and the holotype is the only specimen that is allowed legally, systematically, to be called by the name that was given to it. The rest are just referred. They cannot be named Homo erectus, whatever you want to call them. The other thing is that one thing that's sort of lost in all of this discussion is that, in fact, what's been included in Homo erectus has been by historical accretion, starting with Ernst Mayer's 1950 paper saying everything that wasn't more recent was Homo erectus. But just because you can find some similarities between specimens that have been accreted to this doesn't mean they are Homo erectus. So what to do? Start with the type specimen, sort things out systematically, and see what happens. So I'll just end with this comment Susan Anton made once when I was saying, look, OH9 doesn't look like anything. It's this roundedly triangular profile. The tripe specimen and the material from Sangaran is this wide and low thing. What are you going to call it? So my response is, let's first see how the systematics works out and then worry about calling it something. Thanks.
Okay. So, thanks, Jeff. And We have a lot of time for questions again.
Can
Please.
we turn your argument around and say that if we can find one characteristic common to all the Dmanisi specimens, that therefore you would have to accept that they were one species?
No. No,
Why
because,
can't we turn the argument around that way?
well, because a lot of the things that you would say they have in common are in common with a lot of primates or mammals in general. So what I'm looking for are things that are specific. Is there something specific to all of them that, for instance, would mirror the kinds of specific details amongst the Zhugidian specimens, among the Trinil-Slangeron specimens, the Nangdang, and other specimens? So it's not just looking at any similarity. You could say that an external auditory meatus or an ectotympanic tube is a similarity, but then you'd have to include all catarrhine primates.
So before we come to the last and final presentation of this conference, I just want to say that you might have not seen that on the next page it says conclusions. It should have said conclusions, right? So in fact that will be a panel discussion here, right? So don't run away. Now, we have Kathy Schick and Nick Toth. In our program it says Kathy is giving the talk, but now Nick is giving the talk. And yes, it doesn't really matter who gives the talk. Okay. Early Homo, the Paleolithic record, and cognitive complexity. Okay, so your talk is here. Oh, where is it? It should be right here. Okay, please.
I know what you're thinking. I'll finish as soon as I can. Kathy and I again would like to thank the organizers of this conference for this wonderful opportunity to get together to discuss Homo erectus. And this is our fourth time to Georgia. It's one of our most amazing places in the world to visit. So thank you so much. This is our Stone Age Institute, which we built 12 years ago. Is Don Johansson here? Yes. Don, over 30 years ago, right when I was finishing my dissertation, offered me a postdoc, the first postdoc at the Institute of Human Origins, which I've always greatly appreciated. He gave Kathy and I office space and laboratory space there, and a real salary too. And we've tried to pay it forward, basically, and at the Institute we have hosted and supported over 10 postdocs and pre-docs. This is a conference on the old one of Clark Howell's last conferences. Clark's here in the brown shirt. But behind Henry DeLumley here is David Zavania, representing the Dmanisi team at our conference as well. And we hosted him for an extended time at the Institute. We recently got a fairly large grant from the John Templeton Foundation to study the evolution of human cognition. And among the things that we're going to be doing, 3 years of funding of field work at Olduvai Gorge, Dmanisi, and the Nihuan Basin. We're going to have workshops in each of these countries with participants of the other countries involved in it as well. And we are also funding science education, teacher training, student field trips to museums and sites, as well as exhibits, including the wonderful one that we saw here recently. As Jackson talked about, one of our big projects recently has been the Olduvai Gorge drilling project. This has been a monumental task for us by a power of 10 versus anything we've ever done in the past. We had a contract with 5 companies and the Tanzanian government to make this a success. Just to mention, Kathy and I have spent 40 years working at a range of sites: Kubifora, Ambrona, Peninge, Nihuan, Middle Awash, Gona, and Olduvai Gorge. And this is going to come into play in our impressions about our prehistoric past. We've done a lot of actualistic work as well, making and using stone tools, studying archaeological site formation, doing ethnoarchaeology of New Guinea tool makers, teaching African apes to make stone tools, which I'll be talking a bit about, doing some of the pioneering work in brain imaging and stone technology, electromyography of muscle activity at the Mayo Clinic, and biomechanics and kinesiology of stone tool manufacture. Okay, there's a prevalent thought in evolutionary theory that often behavioral changes, perhaps stimulated by climatic or environmental changes, slowly but surely lead to biological changes. And that's the working hypothesis that we're using for the development of technology and hominid evolution. That it was probably at an Australopithecine grade that our ancestors started making and using stone tools, and it probably took a while for it to really catch on and spread and become really important in their adaptation. So we would expect a lag of several 100,000 years between the earliest stone technologies and evidence of brain expansion in the human lineage. Ralph Holloway, we had a conference at the Institute celebrating his career several years ago. He has three major stages of brain evolution: the early Australopithecine phase, and then stage 2 starting about 2 million years ago with the origins of early Homo, and then stage 3 starting about 500,000 years ago or so with Homo heidelbergensis leading to Neanderthals and modern humans. And major stages in hominid evolution, between 4.5 and 3.5 million years ago, we have evidence of bipedality. We have the first stone tools at West Turkana starting around 3.3. We don't have much until about 2.6, so whether this is an ephemeral event, and as far as we know, this would be in an Australopithecine grade. As Rick Potts has talked about, between 3 and 2 million years ago, major climatic change in Africa. Between 2 and 2.0, we have things that we are calling early Homo based on dental grounds, but we really don't know what the crania look like. And good evidence of Oldewin tools starting at Gona 2.6, and then becoming more common through time. And between 2 million and 1.4, we have the first evidence of encephalized Homo. We have new forms appearing in the archaeological record, spheroids, a lot more retouched flakes, and by about 1.75 million years ago, the earliest Acheulean in the form of hand axes and cleavers. If you count the number of sites in time periods, we're doing this in 600,000 year time periods. We only have one that's older than 2.6, Lemekwi in Kenya. Between 2.6 and 2.0, we have about 22 sites. And between 2.0 and 1.4, we have 67 sites. So we have about 3 times as many after 2 million years ago. We realize we're subject to the vagaries of deposition and erosion that we can find these sites, but it does seem that through time they're becoming more common, more habitual. If we use the number of countries that have early stone tools in archaeology as a proxy for geographical spread, beyond 2.6 million years ago we have 1 country. Between 2.6 and 2.0 we have 5, and between 2.0 and 1.4 we have 11, including Georgia and Israel. So we have the spread outside of Africa for the first time. Our colleague Tom Schoenemann worked on this and gave it to us. These are the These are those 600,000 year time periods we're talking about here. And these are crania that are complete enough that you can do an estimation of cranial capacity. So between 2.0 and 2.6, we have 9 hominids, and they're all Australopithecine. Between 2.0 and 1.4, we have 28, and basically 2/3 of them are genus Homo. The rest are the robust Australopithecines. I want to point out here that we have virtually nothing between 2.5 and 2.0 million years ago. If anybody can find a hominid in this time period that has a brain case large enough for a cranial capacity and a face, we will give you a case of champagne, I promise. And as we all know, in the last 4 million years, the human brain has essentially tripled in size. But if we look at the early prehistoric record, the time period 4.0 to about 2.6 million years ago, we have the form Australopithecus afarensis in this beautiful cranium that was discovered in the Hadar. We have early stone tools at 3.3, and we have a mandible at 2.8 that's being called early Homo based on dental grounds. Again, we don't know what the cranium is going to look like here. And why did hominids start flaking stone tools? If they were nut cracking, perhaps that would lead to fractured rocks and sharp edges. If they were breaking bones to get marrow with a hammer and anvil, that might do it as well. As we've heard several times today, if they were throwing rocks for either offense or defense, one rock might hit another one and cause fracture. So we really don't know how it starts, but you can imagine any of these scenarios being the origins of flake stone technology. Okay, if we look at the time period between 2.6 and 2.0 million years ago, we've got the form in East Africa, Australopithecus garhi. We have also got the rise of the robust Australopithecines, starting with Pithecanthropus ethiopicus. And I just want to point out two things with the robust Australopithecines. They never get to Eurasia, number one, whereas the genus Homo did. And number two, they go extinct by 1 million years ago as well. So clearly, the genus Homo had some edge over the robust Australopithecines. We have more dental evidence at about 2.3 million years ago that's put into the genus Homo by a number of people. And starting with Gona, 2.6 million years ago, and these are some of the artifacts from Gona, we're getting a more continuous sequence of archaeology. Hadar, Omo, Lokalale, Kanjira, and Mohammed's Ain Boucherit. We've had the privilege of working with two bonobos, or pygmy chimpanzees, Kanzi and Pambanisha, teaching them for over 2 decades to make stone tools. We've also given them musical instruments. They've jammed face-to-face, I kid you not, with Paul McCartney and Peter Gabriel. But the interesting thing about Pan is that they've got a brain based to their body size about a third as large as humans, a cranial capacity of about 405 cc's, and a fairly rich technology for a non-human animal. And we did an interesting study. There was a paper published by a group of primatologists in 1999 looking at cultural traits in West and East Africa and how many are shared between different groups. And as archaeologists, Kathy and I asked the question, if you plot these by the number of traits versus geographical distance, is there a pattern? And there sure is. The closer these chimp groups are to each other, the more cultural traits they share. This truly seems to be a cultural phenomenon. Working with our bonobos, we did a 3-species comparison of the Gona hominids, our pygmy chimpanzees or bonobos, and Kathy and I flaking the same rocks. We did this with Seleshi Sama. I just want to say as an aside, all of our Stone Age Institute books, by the way, are online. You can download all the chapters for free if you want to. The Ethiopian government gave us permission to sample the 2.6 million year old raw materials from the Gona gravels. These are where the hominids are getting their raw materials from Gona. And we did a very extensive experimental program. Kathy and I were just trying to produce flakes. We're not trying to make hand axes or anything like that. And we did a very detailed attribute analysis of over 50 attributes on the cores and flakes. These are some of the Bonobo Cores that were produced. If you were a Paleolithic archaeologist, you would have no trouble recognizing these and the debitage produced as being from stone fracture. But if you look at levels of skill, and this is just to kind of summarize, the bonobos were the outgroup, that the Gona hominids were surprisingly skilled in flaking stone, much closer to the way Kathy and I were doing it. I think the bonobos had a harder time recognizing the acute edge angles and hitting in the right place. And biomechanically, they were not producing the same forces of impact as Kathy and I were, or presumably the Gona hominids as well. The other interesting thing is that if you looked at the Gona archaeology, is clearly later stages of flaking represented. This is the Bonobo, whoops. This is, if the technology is recent, like less than 1 million years old, I'm at a loss here. But anyway, this is the bonobos flaking cobbles. They're knocking off about a third of the mass. Kathy and I decided to do about 50% of the mass here. The only way we could produce the Gona assemblages is that you're carrying in cobbles that have already been flaked about 50% of their mass, flaking another 50% of their mass that's left, and then taking the large flakes away. The flakes from the bonobos and our experiments were about 40% cortex. The Gona flakes were 12% cortex, clearly later stages of flaking. So even these very early technologies have a fairly complicated and complex system of moving things around the landscape, clearly taking things to another place in anticipation of later use. And the adaptive significance of these tools, this is an extreme version. This is an elephant that died of natural causes. You see Kathy on the left using a simple Oldowan flake to cut through the hide. And in a few hours, we're able to process hundreds of pounds of meat. These may be exceptional circumstances, but it does show that the simplest technologies are incredibly efficient at animal butchering. And as Nama pointed out, I think she had 6 species of tubers at her sites in Israel. With a simple digging stick, either of wood or other material, you can process all of these underground storage organs. At Olduvai, our paleobotanist thinks that the sedges growing on the edge of the Paleo-Olduvai Lake were one of the most important sources of food for them. That probably would have been helped by digging tools. And then in the time period 2.0 to 1.4, we have early Homo habilis in erectus forms, as we've been talking about. We have the spread into Eurasia. We have cranial capacities going from the 500s, like K&M 1813, and the Dmanisi skull 5, to OH9, which is a little over 1,000 cc's. And we get the rise of the developed Oldowan, especially an increase in spheroids and retouched flakes here, and in the early Acheulean, these classic hand axes and picks, hand axes and cleavers, often made on large flakes, or as at Gona, on large cobbles. What were spheroids used for? Our experiment suggests that if you take an angular piece of quartz and use it as a hammerstone for 4 hours, it naturally and without any thought patterns arrive at this form. So we think these are heavily curated hammerstones, basically. And 4 hours of flaking is producing thousands of flakes and cores. So I think that when you start finding these very heavily battered and rounded artifacts in the archaeological record, it's telling you something about hominids carrying things around consistently or caching them and coming back to them. If you look at Olduvai, these are the sites in beds 1 and 2. This is the percentage of quartz in the assemblage, and this is the number of spheroids. You see there's a very strong correlation between how much quartz you have and how many spheroids. These are the bed 1 sites, which are lava dominated, and you get less spheroids. These are the bed 2 sites, the developed Oldowan sites at Olduvai, and they're very rich in these battered spheroids. Michelle has mentioned we need more fossils. This is my modest contribution to the paleontology of Homo erectus, working with Celesti's team in the Gona area. These are the first 3 of what turned out to be over 24 pieces of the brain case and brow ridge of a Homo erectus, and the Gona team will be describing and publishing this, as well as many more fossils in the near future. All right, and then with the origins of the Acheulean, knocking off large flakes from megacores and producing these hand axes and cleavers. These are from Stellenbosch in South Africa. Experiments have shown that with a heavy hammerstone, you can knock off these big flakes. and produce these hand axes, cleavers, and picks in usually a matter of minutes. And we think these are especially used, we don't think of them so much as Swiss Army knives. We think these are heavy-duty butchery tools for cutting up the haunches of large animals. And both the micro-wear and the cut mark studies at this English site of Boxgrove, an Acheulean site, suggest exactly that as well. If you ask the question, how many cognitive decisions do you have to make an Olawan chopper, or an early Acheulean hand axe or cleaver, or a late Acheulean hand axe and cleaver, you can see that for the Olawan, it's about 11 different types of decisions. For the early Acheulean, about 15, and for the later Acheulean, about 45. And for this and for other reasons, Kathy and I think that the early Acheulean hominids probably behaved and thought and cognitively acted much more like the Olawan hominids, and the later Acheulean hominids probably acted and thought much more like modern humans. In fact, some of the early moderns are associated with hand axes in Africa. Whoops. And in the late 80s, Kathy and I proposed using brain imaging studies to look at brain activity when making stone tools. And this is positron emission tomography. This is some pioneering work we did with our graduate student, Dietrich Stout, who's now a professor at Emory University and just made the cover of Scientific American for his research recently. On the left, you see my brain on stone tools making an Olawan chopper. On the right, I'm making a late Acheulean hand axe. There are a lot of differences that you can see here. And some of the recent techniques that have been used, functional MRI and near-infrared imaging, are giving us a lot of clues about the relationship between tool making and language, for example. So in conclusion, we think stone technology allowed hominids to expand their diet breadth and have a higher quality diet from animal proteins and fats, from hunting and scavenging. And this is basically the idea of Aiello and Wheeler with their expensive tissue hypothesis. This higher quality diet ultimately, after maybe several 100,000 years, allowed for brain expansion through time. Larger brains were selected. There's nothing inherently about making stone tools that makes you smart, or else California sea otters would be heavily encephalized. But we think it was selected for better foraging strategies, social skills, and communication, probably living in larger social groups, as Robin Dunbar would argue, and ultimately geographical spread into new areas as well. Just to end with, this is a painting by Jay Materna showing an Olawan group cutting up a carcass. This is based on a scenario that Kathy and I wrote. And it's exactly the way we described it, except we had a wildebeest. He changed it to a zebra to make it immediately African when you look at it. But I think it's a very cool painting. Thank you. Yeah,
there is a surprise now.
Yeah, at the Stone Age Institute, we don't make a sharp dividing line between art and science. And we have a Stone Age Institute band, which is made up of paleoanthropologists and world-class musicians. We have a song, Homo Erectus, and our guest drummer just drummed with the surviving Beatles for their 50th anniversary concert of appearing in America. This song is called Dmanisi. Kathy and I wrote it. Where's Tom Shinneman? Tom is the drummer in our group.
vocals, Kerry Newcomer. Then guitars and bass, Nicholas Toth. Drums, Tom Schönemann, he's also here. Yes. And David Weber, organ. Okay, great. And the lyrics for this song, Dmanisi, is here on this, and you can take them if you want afterwards. And then, I think you can download this song in the internet. So, please, you should take it at the end, the lyrics, and I'm sure you find this song somewhere in the internet. At least you find some more songs by the Stone Age Institute on YouTube or on their website if you're interested. Okay, thank you very much. That should have been the end, actually, of this session, but we have something. We have a small last session now. A summing up session, okay? We thought, all right, now we discussed for 3 days, you know, Homo erectus and all that stuff, and, you know, enigma and problems and stuff. So, and, you know, at the first day, it was Rob Foley who, he suggested a triple B, whatever, solution, right? Baobab, bush, or braided river. Scenario. So that's why I thought, or we thought Rob would be one of the persons who should come here. Rob. Then we have, sorry, and then Erela Hovas knows everything about archaeology. Almost everything. Erela, you will be great here. And then, of course, David has run around. David, you're not coming? You must come. Please. You're part of it. And then our final joker here, Rick Potts. Okay, so we have Erela, we have Rob, we have Rick, and we have David, and please. And we should take the last 2 minutes for maybe summarizing, summing up, you know, thinking about what we've done here, or what we learned, or what we even learned over the last 25 years. Because in 1991, I remember it was, you know, Homo erectus was sort of more or less the Asian, you know, identification. And then in Africa, there was Homo Augusta, right? And people said, how does all that fit together? Now today, you know, we've thrown everything into one box, right? More or less, I don't know if we have solved any problems with that, but I think we'll give you all a few minutes to give us your thoughts, and then, of course, everybody may contribute from your side. Okay, I think Rob starts.
I'll start. Is that on and working?
Should be.
Is that on and working?
I think maybe you have to press your finger all the time.
I have to hold it down all the time. Well, that'll keep it short. Right. Well, thank you. I don't know if we're working on German time or African time.
You choose. Yeah.
So, can I just start, you know, very, very obviously and very happily to say, you know, this has been the most amazing conference. For me, it's been an extraordinary learning process. I mean, one goes to many conferences and one thinks one knows about something, and one comes away learning an enormous amount about the detail and how the detail forms the platform for going away and thinking about many more things. And in terms of this conference, I think that's absolutely, you know, what's achieved. And that's true in, I think, a number of things, not just the straight facts, but also new methods which are being used here, which certainly need to be employed more widely, and also the number of hypotheses that are out there being discussed. things which you are prepared to die at a stake for, as opposed to those things a politician might just say to get elected. And you have those two extremes of truth. Where do we lie? And to be honest, I think it's very much in paper anthropology I'm prepared to go to the stake for. But it seems to me the most striking thing is the clear certainty that hominins are out of Africa by 1.8 million years ago. And that may seem obvious, and we've had 3 days discussing it, but even 10, 15 years ago, there was still a lot of discussion about that, and the whole issue of older than a million, younger than a million. And I think Dmanisi provides us in a way that the Javanese material has not really been able to do because the dating has been so problematic, and the Chinese the same. It has given us a secure reason for seeing this is the point at which hominins become transcontinental. And that is a major change, I think, in the way we move from the African story to the old world story, and that's important. And the other two things that for me are really solid, the first is hunting, meat eating, and mode 1 technologies. This is the package that's coming out here. And Rick and I are veterans of the old hunting, scavenging, meat-eating, woman the gatherer debates and things. But it seems to me there's evidence here that clearly shows that meat-eating was a big, significant change in early hominin evolution. It gave Homo something important, and we just heard how, these technologies are very important for butchering and for food procurement, and that, is the basis. And the other really striking thing to me was that the fauna is Eurasian. I mean, if you take out Homo, there's nothing here that is very African at all. And to my mind, that says, well, then hominins are behaving differently from other fauna. And I'm not sure I entirely want to say that because I spent a lot of my life saying other things. But it seems to me, one of the issues that we have to tackle in human evolution is asking when do humans behave like any other member of the fauna, and when do they behave differently? And it's those differences that tell us things. And so the isolation of Homo as an African lineage is important to my mind in this respect. Those are, to me, those are the solid things, and everything else comes with a health warning as to whether we really know for sure. And those, of course, become the challenges for future work. For me, the biggest health warning is over what I call the continuity fallacy, and that is that you find something somewhere, and it doesn't matter whether it's the first Australopithecine, the first European hominin, and you then draw a line from there to the present and say that once they're here, then they're always here. And I think we have to remember that Dmanisi, and we've heard very clearly today, is a narrow horizon. Do we have a few hundred years as being the possible scale of the hominins? Now the artifacts range more broadly, but we're still talking about a very small period of time. And I think we have to bear in mind that this might not represent very much to do with later Eurasian colonizations. That doesn't stop it being interesting, it doesn't stop it being important, but I would urge caution in saying if they get here, they stay, that they become part of some great trunk of human evolution. The other health warning is I think we're still a long way from a single story, and I'm a great believer in linking stone tools and hominins together, and I think we have to go back to those, and Dmanisi is clearly going to be important for thinking about how wide-ranging Mode 1 technologies are in terms of the number of taxa that they are involved in. So those are the health warnings. I think what's the politically correct term? We're allowed freedom. Is it enigmas, problems, questions? Challenges. Yeah, our challenges. It's one of those things. And
one of the political correct.
And there are two that I would throw out there, and one we've heard about quite a lot today already. Christoph touched on it in his talk, and I think we very much want to put our fossils, and I'm talking here about hominin fossils, but it could apply to anything, into an evolutionary context. And we tend to think an evolutionary context is one that's long-term. We're looking at long lineages, and that's an important thing we have to do. But I think and Dmanisi really highlights, and the only other place that does the same is probably Atapuerca, that we also
and possibly before we do the evolutionary framework, we need to think about a populational ecology framework. We have to think about this as a population and the patterns of variation at that level and how we scale them up to the evolution. And I think we're a long way from really understanding how to do those two things. But Dmanisi, again, stands out as a place to do that. And the other, of course, is, it's the S word, species. And the issue of, what do we, is this one species ranging, from habilis virtually to Homo sapiens, or is this multiple lineages, as Friedman said? What is it? That's the Baobab model, or is it something much more variable? And the question I would pose is, well, what do you want a species for? What's the point of talking about species? Well, the point has to be because you want it to inform you about something. And I am, I've always been a splitter, and I'm happy to have many species because it doesn't cost you anything, a bit more ink, and it upsets the students because they have more to learn, but that's fine by me. So multiple species are, I think, useful, but they're useful when we're looking at patterns. If you want to understand the pattern of human evolution, I don't think you're going to understand it if you lump everything together, because then you just have to come up with other terms like paleodemes. And species are effectively, Simpson said this, independently evolving units. And if you have independent morphologies over different, back to the geography, geographical spaces, then to my mind they are species. And then we should not be necessarily tyrannized by the Ernst Mayr notion of what a species is, and allow the species concept to be used for what we want to try and do and analyze patterns. If, on the other hand, we want to get at processes of evolution, then we might want to do more lumping, because it may well be that the patterns of gene flow, the braided stream model that I talked about, and they're not going to be very simple and continuous, they're going to be like the Neanderthals show us, very patchy, then we probably want to be much more opportunistic in our use of species and concepts, and it may well be we have to think about biological species and more lumping and subspecies. So I would urge not to sort of think that these are lines you have to divide over, but actually say, well, what do you want your species to do for you in your anthropological, in your paleoanthropological research? And that will guide you, I think, better than a lot of rhetoric. So those are my thoughts on these things, some of them.
Some of them, great. So we have something to discuss. But now I want to ask Arella, please, to give us some opinions or suggestions or criticism or whatever you want. You press that thing or take rows.
Oh, okay. My thoughts are pretty much like the ones Rob just expressed, that they, of course, relate to archaeology. It's been a tremendous learning sessions throughout these 3 days, and I came here, maybe not like you, knowing very little about Homo erectus. So for me, I was just expecting to learn. And we heard a lot about Dmanisi, we heard a lot about Homo erectus moving out of Africa. We heard a lot about new methods and new techniques and new ideas about how to follow hominids out of Africa. And the first thing as an archaeologist that I would like to say is that despite all these cutting-edge, high-tech approaches, which open tremendous venues for research, I think, in the future, I think that fieldwork is invaluable. And this is something that sort of appears obvious, but I think it begins, and often every work that we do begins and establishes itself in the field, because there's no replacement for very strict understanding of the context of the sites or of the deposits from which we derive our information, a clear control over the stratigraphy. I think the talk that we had this morning from Reed was a fantastic example of how meticulous you have to be in the field in order to start and build on this towards the levels that we are aspiring to. Traditional research, or more traditional approaches to research, I think we heard today from Marta and from Maya, some archaeozoological and taphonomic studies that did not go into huge technical innovations, but I think they provided some of the most amazing, and like you said, the fact that the fauna is all Asian or Eurasian as opposed to the hominids, for me this was the first time to hear it, and I think that this tells us a lot about the hominids. And so I would urge all the experts who do the geometric morphometrics, who do the protein studies and other things, do come to the field every now and then. Apart from the sheer fun of it, it's a learning experience as well. Moving on, and again, I think something that relates to what you said, the number of sites, and Nick provided some numbers about numbers of sites per geographic region, per... sorry? Closer, but then it yells at me. Okay. Yeah, but then it's squeaking. Oh, okay. Thank you. The range of time and the geographical range that we are dealing with is the number of the sites that we have. And again, we saw some numbers about that. And I would like to paraphrase Michel Brunet without banging on the table and say we need more sites because we are connecting very isolated dots in these spatiotemporal ranges, and we tell a story. And again, it's exactly like what you said. We draw straight lines from one point to the other, but what happens when you add points to your map? Then things become complicated, and we begin to create archaeologically and presumably also reflecting past behaviors, increasing levels of variation and variability that we need to explain. And this, again, goes, of course, to the issue of variation and straight definitions of what we are looking at. Adding sites, of course, the maybe most recent, most obvious example, adding the site of Lomekwi to our gazetteer of sites, of early sites, produces a record that is by 800,000 years longer than we knew about a year ago, and presents a very new and very interesting and very sometimes uncomfortable questions about the emergence of lithic technology, the emergence of material culture, the pace of which things happen, and so on. And I would agree that another example that we heard from Seleshi is the addition, we heard something about it from Seleshi, the addition of early Acheulean sites, the increased or continuous fieldwork in sites like Gona. We heard about additional Acheulean sites, and we now know that the Acheulean emerged more or less at the same time in Ethiopia, in several maybe parts of Ethiopia, in Kenya. And so, again, there's an enigma. Enigma is an okay word. An enigma here that we need to think about and to try and explain, or to think about its possible causes and reasons in a different way. It's not a point in time where something happens. It's obviously something that happens more or less at the same time, and of course the resolution of our dating always will have something to add on. But it seems to have happened in several places at more or less the same time. What are the processes? What are the causes that might lead to such a record? Looking at the whole range of Homo erectus and also earlier and later hominids, I think a problem that we as archaeologists have to deal with is the problem of scale. The archaeological scale as opposed to the temporal scales, the ecological scales, the scales of climate change. These are very, very uncomparable. Some of it is an analytical issue, so the dating is not accurate enough. But I think even if we have very accurate dates for each and every horizon, archaeological horizon, we will still face the problem of how these horizons, which reflect behavior, correlate, associate, relate to the bigger scale issues of climate change, ecology change. What's the time lag? Is there a time lag? How do hominids respond? And this is something that I don't think we saw an answer to this, or to be truthful, not even much progress. On some issues, yes, maybe we are coming closer, but I think that the distance is still very big. And I would just like to remind us again that association is not causation. The fact that things happen more or less at the same time, and one might explain the other, does not suggest that they actually explain the other. We need to come up with an explanatory model that would correlate the two phenomena in a better word, in a better way.
Okay.
Yeah, I could go on, but
yeah,
that's part of it.
It's very interesting to listen to. But I think I'm not convinced if Rick would not be of a different opinion of what you said just now in your last sentence about the big picture and the climate and human evolution.
Okay.
I mean, that was his topic at the beginning. So, Rick, you have a chance to...
No, I'm going to go beyond that. I'm impressed by the great diversity of questions, the scale of questions that the study of the Dmanisi site and its finds raise. Many challenges of interpretation have been made available to us at this conference, and that's been terrific. I'm greatly impressed, nonetheless, by the progress, by the variety of researchers and the data sets that are being developed and have already been developed. With regard to the scale, what I mean by that is that there are challenges of geology and taphonomic interpretation, for example, that Reed and Martha and others on the team have addressed in really productive ways. And these get to the questions that are at the scale of the site interpretation itself, the site and its stratigraphy. We haven't really had a chance, of course, to, except individually and idiosyncratically involve the posters in this, but I was impressed by a couple of the posters that spoke to raw materials and perhaps of stone raw materials, and perhaps we'll hear more about that tomorrow when we're at the site. One poster saying about 50 different types of stone material being used in the stone tool-making process. Another poster suggesting that about 6 of them, or 7 of them, were used predominantly. And so what's involved with that kind of selectivity, what is learned about ranging patterns of the hominins who brought stone material to the Dmanisi site is a very interesting and important question. So those are the scales of the site and site interpretation, but then the recovery of the archaeological remains and, of course, of the hominin fossils raises much broader, many broader questions about the behavior of Oldowan hominins in general, how they were able to adjust to different contexts in Africa and Western Asia, Eastern Asia, and so on. Of course, the evolution of early Homo, questions of species recognition. And one of the things that I think is one of the most underestimated aspects of and unstudied aspects of in human evolution, which is the biogeography of human evolution and the process and factors involved in the dispersal of Homo. But nonetheless, we've heard some interesting ideas and suggestions during this conference. And then far away from Dmanisi, matters that reflect, that may be related to the development of the complex set of morphologies represented in Europe later in time, and also where was, and what was the origin of Homo floresiensis when dealing with Southeast Asia. Rob touched on that in his introductory talk. So I'm certainly impressed by a wide variety of questions. I'd like to just emphasize 2, perhaps 3 of them in particular. One, of course, has to do with the variety of talks today about the variation in Homo erectus. One of the things that I thought it would be interesting to just reflect on in a sentence or two here is that the really interesting talk by Anne on dental pathologies, and also the talk by Marcia on the age spectrum and developmental properties, morphological properties of the Dmanisi sample. It seemed to me that these affect dental pathologies and the wide range age spectrum that we have represented by the 5 skulls certainly would affect morphological variation and its assessment, and whether indeed African fossils that are typically placed in distinct taxa, such as Homo habilis, should these be included in Homo erectus? And I think that that has not been addressed as effectively as it should be. I think that there are aspects of variation and causes of variation in the Dmanisi sample related to these pathologies and the wide developmental spectrum that need to enter into the picture before we begin to lump everything in Africa around that time period in Homo erectus. I also was thinking while hearing those variety of talks about, although it's quite fragmentary, OH62. And I happened to mention this to Martin Hausler at lunch. Yes, indeed, it's quite fragmentary, but it would be, if indeed that represents Homo habilis, it would be very difficult in my mind when taking a postcranial approach to what is Homo erectus to include it as part of the gene pool that is represented at Dmanisi. And so we shouldn't forget that there's not just heads rolling around dispersing across the globe, but rather that there are postcranials too, and we need to incorporate that into our thinking. And so I would suggest that Homo habilis, as represented in Africa, still represents a recognizable and distinct gene pool from the Homo erectus paleodeme represented at Dmanisi. The other question has to do with dispersal. Oldowan hominid behavior is represented then from East Africa, South Africa, East Africa, Dmanisi, Eastern Asia as well. And as I emphasized in the talk I gave, it suggests that there is a really pretty amazing capacity of Oldowan hominins to adapt or adjust their behavior to a wide variety of ecological situations. And that suggests that in addition to the stone tool making, that aspects of social care that may be implied by the edentulous skull from Dmanisi and social cooperation need to be certainly incorporated into our understanding of that. I would say that also included in that, while I would somewhat agree with Rob when he said, hunting, well, I wanted to cover my ears at that. Early access to carcasses is clearly represented there. But the hunting represents a wide variety of different approaches that can't, in my view, be distinguished from archaeological sites of that age. And so it's really that I would say that dietary diversity is critical to examine. Nama's talk on dietary diversity in the Acheulean at GBY really needs to be also part of our thinking about the Oldowan. I'll leave it there.
Okay, thank you very much, Rick, because we're only about 55 seconds away from our official closing time. So Arella, Robin, Rick, I thank you very much for giving us your thoughts for the final discussion. I suggest that we can continue discussing these things during dinner tonight, during excursion tomorrow, and so on. So I think we are at the end of our session. I want to say two things. Your posters are outside. You can, the ones who brought posters, right? Not that you take anybody's poster, except you talk to the colleagues before whether you can take it. Okay, anyway, the posters are there and you can pick them out there the roles where they're in, they're also out there. That's one thing. And the other thing is that we are considering publication of this conference, right? And we will get into contact with you very soon about this. Okay, so I thank everybody here, of course you, of course David, of course my co-organizers Angela and Ottmar and everybody involved in this conference, and of course I thank all of you for coming all the way to Tbilisi from 25 different countries. It's great that we are going to go to Dmanisi tomorrow, and who has not been there yet, I think it will be great and fantastic for all of us. Okay, and David, you also want to say a few words?
I will say also thanks, and you see, it's sometimes, you know, I was born in mythology, Greek myth, and all these kind of things, and always were believing that myth can happen in reality. And how I could imagine, you know, when I started to read this book, which changed my life. This is Russian version. Then I was student, and may I have, this was my favorite book, Rob Foley's, and now we are together. Dmanisi got even song for it, and that's what else you want, right? So, and I want to say that everything can happen. Just make more wish, right? And thank you very much, everybody, for coming. Okay, and, Georgia, no, hold on a second. In Georgian table, you can speak a lot, eat and lot. So we can continue it symposium during this dinner.
But right at the end now, I want these four ladies I mentioned at the beginning. Can you please come here? Claudia, Birgit, Mariam, Nadia. Please come here. David. Let's go and give them something. Because these four ladies, as you know, they did all the organization, the background for this conference, you know, since many months. This was a Frankfurt and Tbilisi cooperation project. And we are very thankful to you for the job you've done. And I think everybody agrees that was organized very well to the last, you know, moment of picking people up, taking to hotels and everything. So I think it was a wonderful experience, and you've done a great job. So now.
Before we will finish, you know, I want to ask you know, we are not giving flowers to men in Georgia, but during the war, you need always logistic, right? I want to present a man who you never saw before, but all logistic was behind the scene was him, and thank you, Goga. We can start 7:30 moving towards real symposium, right? Thank you very much.